So this is a little baby lesson. We used to spend a lot more time on this, doing them by hand and trying to make sense of all this, but it's not something you're going to use a whole bunch, and so I have shortened it down to a calculator fun lesson, okay? Now, just to get you into this little fun lesson, I'm going to take you to a little website here. Let me move this thing down. Well, what? Yeah, it is a super long link, and I couldn't figure out how to shorten it because I did a search, and that's how I got to the page that I want to show you. The problem is it's a search page. It's not a... These are all done with polar equations. How fun is this? Look, this one even has the equation you can type in if you want to try to get it to graph that. Okay? I kind of had an epiphany while I was doing this. Does anybody remember what a spirograph is? Or you ever had some kind of little thing where it was round, you stuck your pencil in something and you went round and it drew a picture? It's polar graphing because it's going round and round, and the number of little spokes on the thing told you what it turned out like. It drew stuff like this. I never got one to draw a heart, I know that, but this is what my spirograph, this is the ultimate spirograph right here. But I got to tell you, there's some school inappropriate ones on here. See if you can find them here. There we go. Okay. But there are some pretty cool ones, so I just wanted to show you. All right. So these are polar graphs. All right. Now going back to this. I'm going to do this one by hand just to review how you graph these. Jacob, were you gone Friday before break too? Okay. So the introduction to this, anyway, this was 0 rotation out 1. That would be right here. Everybody agreeing with me? Pi over 6 out 2. So here's pi over 6 out 2 radii. Pi over 4 would be this line. We're supposed to go out 2.5 roughly. Pi over 3, we're supposed to be out to 2.7. Pi over 2 up here, we're finally at 3. But then it starts going back. Over here at 2 pi over 3, it's at 2.7. 3 pi over 4, it's at 2.4. 5 pi over 6, it's at 2. And pi, it's at 1. Basically, we have a circle so far, yes? Kind of looks like a circle. Okay. But the problem is now we're going to do this second half over here. And as we continue around, it says 7 pi over 6, you go out nothing. So you're still at the, does anybody remember what that's called? Not the origin anymore. I would call it the center. It's called the pole. Okay, the pole. And this is called the polar axis. This line over here. Okay, I'm going to need that in a minute. All right, then it goes around to a 5 pi over 4, which would be here. But what is this negative 0.4 business? Yeah, we got to back up into this quadrant about half of a space. Now all of a sudden we have a dot in our circle, right? Actually, this wasn't a perfect circle to begin with, but now we go to 4 pi over 3 and we back up almost to 1. At 3 pi over 2, we do back up all the way to 1. And then we keep going. Okay, I'm just going to fill the rest in here. What we get is called a limacon. It kind of looks like a lima bean. There's actually a little dip here. It kind of does that, but then it comes around. This one is called limacon with inner loop, maybe your brown sheet says. Okay, it's got a loop in the middle here. Now, what I did to get those values, guys, I put in 0, I put in pi over 6, I put in pi over 4, and got all these decimals. Who wants to have to graph all these that way? Miserable, right? Miserable. So thank goodness we have the technology to do this. This one got, there's the word, guys. It's called limacon. Okay, that's what that thing is. We're going to do this one on the calculator. You need to be in polar mode, in radians, and go from 0 to 2 pi. I also did -5 to 5 for my x. -5 to 5 for my y, and then I did do a zoom square just to make it look nicer after I faked it into the -5 to 5. Will you please, if you borrow one of my calculators, make sure it's in function mode when you return it, or some poor child is going to try to graph a parabola or a line tomorrow during the SAT test, and it's going to say r and theta, and they're going to get real confused, okay? Because Precalc would be the only people who would know how to put it back into function mode. Everybody else just uses function mode. All right, so what did you get for this guy? 2 cosine 2 theta, is that what it says? Right underneath my little thing here, 2 cosine 2 theta. Did you get a little 4-leaf something? Are you in radians? That's my first question. Now did you get a little 4-leaf something? Okay. Can you tell how long the leaves are? If you try to trace, okay, you might want to do this and just remember to put it back. But if you go second zoom, you can turn on polar coordinates at the top up here instead of rectangular coordinates. And then when you do trace, it should start at 2, 0, which tells you that this was 2 units out to that one. All right, then they're all the same size. So I'm just going to roughly go, is that 2? Yeah, that's 2. Okay. Oh, yeah, looks nothing like that. Phew. Okay. That's my bad picture. Everybody okay? Now, I'm going to tell you a little secret, okay? The little secret is that 2 cosine 2 theta, this 2 tells you how long the leaves are. And this number back here, if it's odd, it tells you the number of petals. If it's even number, then there are twice that many petals. So the fact that there was a 2 here meant they were 2 units long. The fact that there was a 2 back here meant there were 4 petals. The fact that there was cosine means it has symmetry with the x-axis or the polar axis, but that's the next part of the lesson. First of all, we're going to just graph these. Can you do these 3 real quick? What's this one? 2 sine theta. Anybody get something? It's just a circle whose diameter is 2 though, right? You can use your brown sheet for this quiz, the tan sheet, and it does have a little bit of hints about stuff that's really badly drawn. About what they should look like. 2 plus 2 sine theta. The plus tells me it's another lima bean looking thing. This is actually on your sheet when it doesn't have the inner loop. I didn't do this very well because I think I was supposed to go all the way up to this one. I was supposed to go up to 4, I think. Ooh, that's really bad. It's called a cardioid because it kind of looks like a heart. This one is a little round, so it kind of looks like a butt. That's what they told me. To look like a butt. Here's where I'm talking about, guys. On the sheet, on the brown sheet, this says with a loop inside, limacon with an inner loop. When it has the little dip here, it can be either called a dimpled limacon or a cardioid because it looks like a heart. All right. You don't really have to know that vocabulary. There is a question, but it's not on the quiz, I don't think, about what it's called. One more. Is this one a flower? No? I don't think it is a flower, is it? Is it another lima bean thing? I know it's not a flower because it has a plus or minus. That plus or minus doesn't make it a flower. So it's loop 1 over here, yes? I don't know how far it goes, almost to 3. Okay. That's about how accurate you have to be on your homework on this. And on the quiz, it's matching, I think, okay? You don't have to try to sketch these accurately. Does that seem all right, guys? All right, I want to go back and look at 1, 2, and 3 again, but I want to talk about symmetry with them. This looks like y-axis symmetry, yes? This graph right here, the blue one on this picture, can you see it? Looks like it has y-axis symmetry. Only there is no y-axis. That line is called theta equals pi over 2. Remember that? A line is theta equals, and this one could be called pi over 2 or 3 pi over 2, I guess. This one looks like x-axis symmetry because you can fold it right here. Okay. There is no x-axis, though. It's called the polar axis. And this one we're not going to talk too much about, but this is origin symmetry. Remember that business? Where anything, if you take the opposite, switch it around, it's all crazy rules here. All right, origin symmetry, but origin is called the pole. All right, so I want you to go back quick and tell me the symmetries. What do we have here for this? Go away. What's number 1? The symmetry is here, so what is that called? We don't have y-axis anymore. What is that line called? Y-axis isn't called the y-axis anymore. Yes. All the points where theta is pi over 2, no matter what the radius is, would make that line. Okay, and that's the kind of symmetry it has. All right, what about number 2? Same. And number 3? It's supposed to kind of look like x-axis. My picture is horrible over there. X-axis symmetry is called the polar axis. Okay. Please notice that the two that were y-axis were sine graphs, and the one that's x-axis is cosine, right? Okay. All right. There's a bunch of tests. It says it on your paper, talks about how you could test for symmetry. I didn't put symmetry on the quiz, so I'm just moving on. It's a deal? Told you I was going to make this short and sweet. Okay. The only thing on the reference sheet I really want to go over, though it explains what stuff is here, guys. It says if you have a number cosine theta or a number sine theta, you get a circle. It says up here if you have a plus or minus b cosine or sine, then you get some kind of limicon, and it tells you how you can determine which it is. This is what I want to talk about right up here. It says you get a rose if you have something times cosine something theta or times sine something theta. Okay. It says n is the number of petals if it's an odd number, and it's 2n petals if n happens to be even. And the number a tells you how long the petals are. So I went over that kind of fast, but can anybody tell me what like 3 sine 4 theta would have? The number inside tells you petals, and it's even, so it's actually doubled. So it would be 8 petals, where each one is 3 units long, okay? And the symmetry, it would have symmetry with the y-axis. That doesn't necessarily mean that it wouldn't have symmetry with the x-axis. It can have both. All right, moving all the way to this question. Can you predict what this might look like, guys, before you tried it on your calculator? Careful. It's only doubled if it's even. This is odd. So this is 3 petals that are going to be how long? 4 units long. Now, we could draw 3 petals in a lot of different places, right? If you graph it on your calculator, you will see that one of the petals is right down here. Now, if there's 3 of them, how far apart till the next one? 360 divided by 3? 120. So if we went from down here, 120 would be 90 plus 30. It would land here. And another 120 added to 30 would be 150, which would be this guy right here. Boy, I drew that really bad. Really bad. Okay. What kind of symmetry does it have? Mine has none because I drew it so badly. But it has symmetry here with theta equals pi over 2. Okay. Number 5. What do you think about this one? 3 units long, but even makes it 4 petals. Yes? Yes. Oh, it was supposed to be out to 4, and I only went to 3. Yep, you're right. These should have been longer, guys. Thanks. My bad. Okay. This one has 4 petals, 3 units long. Are they right on the quadrant lines, guys? Anybody graph it on your calculator? Three cosine. What did it have there? 2 theta? Because I covered it up. Okay, 2 theta. All right. We good? 3 units out would be to here, to here, to here. Okay. Oh my goodness, I don't know what that is. All right, anyway, what kind of symmetry? It actually has multiple symmetries. It has to have, because it's cosine polar, yeah. It actually has multiple symmetries, but we'll just move on. Okay, this is the next one. Are we already to 6? We're almost done. Okay, number 6. This is the graph we just did. So what did we get? A rose. That was easy. Number 7 is a little bit tricky. There's the point right over here. So it looks like 3, 3, 30. Does that everybody agree that that's what it looks like where that dot is on your paper? But it says we need to name it between 0 and 180. 150. Oh, you guys are good. Everybody okay? Around to 150 and then back up 3. Now, can anybody give me another name that doesn't necessarily fit in here, obviously, but... Oh, negative 210 and negative 3. I didn't even think about that one. You're right, negative, negative. I was going to go with you could back up just 30 degrees and go out 3. All right, but this is the one they wanted. Everybody good? Okay, couple more questions. Number 8, I don't even think I gave you graph paper. I apologize. Does anybody remember what this looks like, though? It's just a circle whose radius is 3, so it's this guy right here. You can just skip it on your notes if you want because we don't have graph paper. All right, this one's important. This concept is on the homework check, and miraculously, when I graded a bunch of them from earlier today, they plotted the points and then turned the paper in. It says find the distance between them, okay? Got to do a little work here. 3, 150 is 150, 1, 2, 3, right there. Negative 245, a little bit tricky. Go around to the 45, back up 2, so it's over here, right? All right. So this one was 3 units from the pole, and this one was 2 units from the pole. And we need to find this distance in between them. Okay. The problem is we need to find the angle in between them. Can anybody give me another name for this one? that has a positive? 225 if we add 180? Okay. That becomes a lot easier to find the angle between them now, because look, how far is it from the 150 line to the 225 line? All right, so now do you remember how we do it? What do we do now? Law of cosines. 3 squared plus 2 squared minus 2. That 2 is part of the formula. And then the 3 and the 2 and the cosine of 75. Okay, type, square root. One, what'd you get? 1 point, are you in degrees? There we go. Degrees, right guys? Yeah, I was gonna say, I think it's gotta be more than 3 or 2. 3.1, anybody else get that? I did it this morning. It's on my calculator somewhere here. Yeah, I got square root of 9.89. So it's like 3.14. Well, good. All right. Number 10 is just graph. You guys can do that, right? Is it a lima bean or something? Okay. Number 11. We're supposed to write an equation so that she can make some pretty stationery. It says she wants 8 petals with them being 4 units long. Any ideas? Which number goes out front? The 4 units long. If this is 8 petals, it's even, so we got to divide by 2, and we get a 4 back here. I heard sign. Does it matter? It didn't specify. These are 2 different graphs, but they would both be 8 petals, 4 units long. They just have different, they're tilted a little bit different. So if you do these on the same graph, you get 16 petals. All right. Please notice that this book assignment is actually on worksheet 8, okay, guys? Worksheet 8 is where you do it because I gave you graph paper. Now, if you're going to do SAT prep the rest of the period with me, please put your calculator back in function mode for those little children who have to borrow these calculators, okay?